Hello students. Today I want to talk a little bit about the rules of exponents. The rules of exponents are something that people oftentimes struggle with. Sometimes instead of rules of exponents you might have properties of exponents. Basically the same thing. So there's a few different ones I want to talk about today. The first one that we'll talk about is what I will call the product rule. Product rule. Now, before we talk about the product rule, let's talk about what makes up an exponent. So exponents very generically can be written b to the x, where b is the base and x is the exponent. Okay, so that's very generically. You can see it in other forms too, but that is what the most generic one, and that for the most part will be good for what we are going to do in this lesson. So the product rule states that if you have x to the m times x to the n, in this case x is being our base and m and n being different exponents we have, this is the same as x to the m plus n. And so to help us to see this rule, I'd like to do an example. Let's say we have 2 to the third times 2 to the fourth. What we see here is 2 to the third, right? That can also be written as 2 times 2 times 2, while 2 to the fourth can be written as 2 times 2 times 2 times 2. So here we just have a bunch of multiplication of 2's going on. So we have 1, 2, 3, 4, 5, 6, 7 2's. So we can write this as 2 to the 7th power, being exponents, it's just repeated multiplication. Right? So another way we can write this is 2 to the 3 plus 4, or 2 to the 7th. And we see that happening down here in our product rule. And so hopefully that helps explain one of the rules. So something to kind of keep in mind is if we have x to the m times x to the n, right? Our base is the same. But our exponents, they could be the same, they could be different. But as long as our base is the same, right, in this case x and x, or 2 and 2, we are able to rewrite it as x to the m plus n. If by chance we had something else, and let's say we had 2 to the third times 3 to the fourth, so now our bases are different. This is the same as 2 times 2 times 2 times 3 times 3 times 3 times 3. And because of this, right, we can't just have a single base. Right? We have different bases we're dealing with. So we can't rewrite this as like 2 to the 7th or 3 to the 7th because we have different things going on here. And so that's an important concept. Oftentimes what I will see is I'll see something like x to the cubed times y squared, and somebody will try to do like x y to the fifth. But that is not correct. That is a train of thought that would get you the wrong answer, right? Because it would be kind of rewriting this as 2 times 3 to the fifth, and right, when you think about it like that, when you actually plug some numbers in, you see that it does not necessarily make sense to do it like that. Okay. The next thing we want to do is we want to be going over the power rule. And so I just want to move the screen down here a little bit. So let's move the screen down and let's talk about the power rule. So power rule. So just as if we raise something to a power, like x to the second power or x to the fifth power, right? There's power rules, and there's different ways we can write this. So we could do x to the third power, and that's the same as x to the third power. So in this case, let's say we have x to the m to the n. This is going to be the same as x to the m times n. And I'll show you why here. Let's take this x to the third power that we have up here, but let's add to it. Let's say we have x squared to the third power. Well, we can rewrite this as x squared times x squared times x squared. And we can further rewrite that as x times x times x times x times x times x. Right, so here we see we have 6 x's. So that's the same as x to the 6. So, as I said, this we can rewrite as x to the 2 times 3 or x to the 6th power. Okay. So that's kind of what's going on with the power rule. The next rule I'd like to talk about is what we call the quotient rule. So quotient. So I think I've quotient misspelled there, so please pardon my spelling. Quotient is just another word for division. So it's kind of like the division rule. And so what you can say here, so if we have like x to the m divided by x to the n, this is the same as saying x to the m minus n. And I'll show you kind of why here. Let's use x to the fifth divided by x to the third. So if I have this going on, what I am able to do is I can rewrite this as x times x times x times x times x over x times x times x. Right, and well, we've got 3 x's here. Right, another way you might write this is also x to the cubed times x squared. Right, if we're using our product rule, right, that's the same as x to the fifth over x cubed. Right, so we get x cubed times x squared over x cubed. And if that's the case, you may be able to break that apart. X cubed over x cubed times x squared. And well, anything over itself just becomes 1. And so we can say this is just x squared. So the question is, well, what else is going on? How else can I see that? Can I get an example? And so let's look at an example. Let's say we have 2 to the fifth divided by 2 to the third. Well, this would be the same as 2 to the third times 2 squared over 2 to the third. And I can look at doing what some people call a giant 1 right here. They say, oh look, we got a giant 1, and so 1 times 2 squared is just going to be 2 squared, which is the same as 4. And so in summary, the quotient rule, x to the m divided by x to the n, each and every time will be equal to x to the m minus n. So hopefully that's helpful with the quotient rule. And so that's a couple more of the rules down. Now we would like to talk about the zero exponent rule. And so the zero exponent rule, zero exponent rule, states that if you have x to the 0th power, that's going to be equal to 1. And that might seem pretty odd at first. And so let's talk about and kind of what is going on at this case, what's causing that x to the 0th to be equal to 1. So first off, let's look at x to the 4th. If I have x to the 4th, that's the same as x times x times x times x. Okay, and I think at this point we should have that understood pretty good. Now let's look down lower, and let's look at x to the 3rd. Well, that's x times x times x times x. Oh, sorry, not that last x. So we got 3 x's. And to get from x to the 4th to x to the 3rd, what we did is we divided by x. And if we divide by x one more time, we'll get x squared, which will just be x times x. And if we continue that pattern of dividing by x, right, x to the 1st, well, anything to the 1st power is itself. That's just going to be x. And let's continue that pattern one more time. And now we get x to the 0th, right? We're going 4, 3, 2, 1, 0. And what is going to happen here is we're going to have x over x, right? So we took this and we divided it by x. Well, anything over itself is 1. Okay, so that's the zero product property and kind of where it comes from. X to the 0th power is 1. And that leads us to ask the next question. What would happen if we divided by x again? Okay, so now we're going to go into the negative numbers, x to the negative 1. Well, 1 divided by x is 1 over x, right? Or you can say 1 over x to the 1st. Usually if it's just to the 1st, you don't. And then if we continued that division, right, x to the negative 2 would be 1 over x squared. So whenever you see a negative number, right, you can rewrite it as 1 over x2, whatever that number was in that exponent. So in other words, if you have x to the negative m, you can rewrite that as 1 over x to the m. And that's kind of what we call the negative exponent rule. Negative exponent rule. Right. So as you can see, the zero exponent rule, the negative exponent rule, they relate to each other quite nicely. And hopefully these couple rules will help you out. I'll make another video on fractional exponents because that is, in and of itself, can be kind of lengthy. But hopefully these rules of exponents are something that will help you.